Christian Mordarski, and I'll be explaining what the combined gas law is. The combined gas law is a law that just combines Boyle's law, Charles' law, and Guy-Lussac's law. The formula for it reads pressure 1 times volume 1 over temperature 1 equals pressure 2 times volume 2 over temperature 2. It's very easy to remember as long as you know Boyle's law, Charles' law, and Guy-Lussac's law. There's no new information. All you're doing is combining the three laws into one. So when the amount of gas is constant, the combined gas law describes the relationship among pressure, volume, and temperature.
Hi, this is Caroline, and I'll be talking about how to do the combined gas law. First, you're going to use the formula, which is PV over T equals PV over T. That is shown also right here as well. Because this problem requires that we get volume, we put the equation equal to the volume. The equation is now V2 equals P1 times V1 times T2 over P2 times T1. The next step is to plug in what we know. We know that V1 equals 30 liters, T1 equals 313 Kelvin, P1 equals 153 kilopascals, T2 equals 273 Kelvin, P2 equals 101.3 kilopascals, and we don't know V2, which is what we were trying to find. The last step is to cancel out the units and do the actual math. This comes out to 39.5 liters, which is exactly what the answer is.
Hi, this is Reed Spears doing the real-world example of the combined gas law. For this part, I will be doing two different real-world examples. The first problem is a cylinder contains a gas of volume 30 liters at a pressure of 110 kilopascals and a temperature of 420 Kelvin. Find the temperature of the gas, which has a volume of 40 liters at a pressure of 120 kilopascals. The formula will be pressure 1 times volume 1 over temperature 1 equals pressure 2 times volume 2 over temperature 2. We can make a data table to start. P1 is going to be 110 kilopascals, V1 is going to equal 30 liters, and T1 is going to be 420 Kelvin. The second part is that P2 is 120 pascals, and V2 is 40 liters. Keep in mind that T2 is X because we don't know the answer. When you plug the data table into the equation, this is what you get. From here you can further simplify the equation into this. Now when you divide 3,300 from each side, you get the answer that the temperature is 610.91 degrees Kelvin. The next problem is a cylinder contains a gas of volume 10 liters at a pressure of 80 kilopascals and a temperature of 200 Kelvin. Find the temperature of the gas, which has a volume of 20 liters at a temperature of 220 Kelvin. The same formula will be used. Once again, we can make a data table. P1 is going to be 80 kilopascals, V1 is going to be 10 liters, and T1 is going to be 200 Kelvin. P2 will be X because we do not know what the pressure is, T2 will be 20 liters, and T2 will be 220 Kelvin. When you plug the data in, this is the equation that you will have. The first step is to simplify, and it will lead you to this equation, where you will divide 20 into 880. The final answer is that the pressure is 44 kilopascals. Thank you for listening. This was Reed Spears presenting the real-world uses of the combined gas law.
And here's our demo.
This works because as you immerse the can in cold water, the pressure on the outside is greater than the pressure on the inside. Thank you for listening.